Welcome and thank you for joining us for this webinar presentation. We are the Cybersecurity and Information Systems Information Analysis Center, or CSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTE&A, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. CSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the cybersecurity and information systems community. As such, our organization supports those working in the cybersecurity and information systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the cybersecurity and information systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD cybersecurity and information systems research.
Good day, everyone. Thank you for joining today's webinar presentation. My name is Philip Payne. I am the technical lead for the Cybersecurity and Information Systems Information Analysis Center. Before we get started, I would like to note a couple of administrative items. First, if you are dialed in by phone and would like a copy of the slides that were posted to the CSIAC webinar announcement, you can go to csiac.dtic.mil/webinars and find today's webinar. When you click on it at the bottom of the announcement, it will say download presentation. Second, all participants are muted, but feel free to chat using the attendee chat window on the lower right-hand side of the webinar screen. You can use that to chat with each other, and I'll be monitoring that chat as well. However, if you would like to pose a question for the Q&A session at the end, please click the 3 dots labeled More/Panel Options to bring up the Q&A window as part of your layout. At the end of the presentation, I will go over the Q&A. For the benefit of those on the phone, I will read the questions out loud to the presenter. If you have any technical issues during the presentation, please have no fear. The full presentation will be available online. Please check back to the CSIAC website once the webinar is posted. The Go To Webinar button will take you to the YouTube link. With that said, I would like to introduce Sarah Jordan and David Sparrow from the Institute of Defense Analyses for today's webinar.
We good to go now?
Yep, all yours. Take it away.
Okay, so this is a treat. We spent a lot of time last fiscal year on developing the guidance for early and developmental test and evaluation of AI-enabled systems. This is what we called it to emphasize the importance of model and component testing early on, although the official government version just starts with developmental test and evaluation. The information is down in the corner. Administratively, the entire talk is based upon the government document, which was released in February, which has been cleared for public release. Okay, next chart. Okay, this is what we're trying to do. We're going to give you some background on the guidebook, so where it came from, what was the motivation, go over the content with intermittent light touch and high details, and spend a little time at the end on what we're sort of hoping. Of course, we're hoping you'll download a guidebook and it will be useful to you, and you'll participate in a question and answer at the end and provide feedback over the long term. The current plan is to come up with an updated version, probably in the next fiscal year, and any interest you have in participation would be welcome. I will say, for the way in which we put this together, on the first draft, we spent a lot of time, a lot of our calendar time was spent interacting with the broad community and making sure we had either captured or built the consensus necessary to produce a useful guidebook. And I think we want to go down the same path again the next time. Okay, next chart. The next chart's an easy one. It's the context where it came from. So let's press on. Excellent. There's a lot of things happening, not just in AI, but in autonomous systems, improved to software, increased attention to cyber. And a number of policy documents came out from both R&E and DOT&E, including supporting documents as well. If you look over at the left-hand side, there were a number from DTE&A. The AI systems one is part of what we will emphasize today. And I will take this opportunity because there were cyber guidebooks that came out as well. There's a bunch of important things we didn't do. And the three obvious ones include cyber. It's the cyber systems, the generative AI, and work with the safety community. There were three reasons that covered all of them. One was expertise of the team. One was the schedule pressure we were under. And the third, but perhaps the most important one, is there were these parallel efforts going on. And the last thing we wanted to do was have multiple issuances of guidance which covered the same topic inconsistently. So there was almost nothing on cyber in the guidebook, but we hope this will prove useful to you anyway in terms of understanding the broader T&E issues of AI. Okay, on to the next. The challenges we have, in T&E, not unrelated to the challenges in development, the challenge especially in T&E is that we have these systems which have multidimensional sphere of regard and often very sensitive responses to small changes in input. So you're put in a position where if you try to do traditional comprehensive testing, you have a vast space to test and you have to sample it very intensely. So the challenges mostly drive back to that. These were recognized almost a decade ago in some of the early DSB work, but I don't think it was quite captured at that time as this issue that you've got this enormous state space that you would like to be able to sample intensely, and you flat out, there's not enough time to the heat death of the universe to do it. The issues are it's difficult to predict outputs compared to more algorithmic approaches. I mentioned the small changes leading to big effects. And one of the qualitatively new things is that the challenging parts of AI, which are the machine learning parts, particularly those with deep neural nets, are dependent upon training data in a way which is a qualitatively new feature. The artificial intelligence efforts that do not make use of machine learning, for the most part, can be tested the same way traditional software is tested. But the emphasis on machine learning has largely driven the need for a new guidebook. Okay, next chart. Got another easy one. I'm going to sketch quickly the guidebook through the table of contents on the next chart. We have a generic introduction, a description of DT&E of AI-enabled systems, which is primarily to remind people that although a tremendous amount of the attention on developmental test and evaluation is focused on a combination of contract compliance and full-up system behavior toward the end of the development, a tremendous part of the important activities happen very early. They happen under the rubric of characterizations of risk and characterizations of performance, and these are essential for the support that's part of the DTE&E mission for supporting both the system engineering and the acquisition process. So part of what we wanted to do with this was emphasize this characterization function of the technologies that go into the full-up systems. The meat of the report is in the AI-driven changes to T&E practice. There are a bunch of things that are just going to have to be done differently. And then we devoted a chapter to what we call expanded interactions. AI tends to cut across all the stovepipes that the Department of Defense has so carefully erected. And the way of dealing with these stovepipes, if you don't have the political clout to make them go away, is to basically talk to everybody in the other stovepipes. So it sort of outlined some of the expanded interactions that we believe are going to be necessary for the T&E community to engage in. And then, of course, we have a glossary. Okay, on to chapter 2. We talked a little bit about AI-enabled systems, the DTE&A activities, which I emphasized before. One of the things I want to emphasize here is that CDAO has put out a series of strategic frameworks for how to do test and evaluation, sort of divided into 4 elements: the early model testing, the human systems interaction, the system integration from the sort of model developed in the lab to the model as embedded in the system, and then finally mission-informed testing. The work is very good. It's a starting point for anybody who wants to get engaged in this stuff. And then we spent some time on the implications of AI for how you do the developmental test across the life cycle of the system. All right, next chart. And one of the taglines we have, the things in quotes is language lifted directly out of the guidebook. The comprehensive testing is no longer feasible for either the components or the AI-enabled systems. And this is a driver, and a fair amount of attention goes to how it is and what you can do to wrestle with this fact. The testing and measurement will remain paired to the models, and to some extent to the full-up systems with the models embedded. The evaluation has been much more complicated because we need to draw conclusions about situations that may give very different behavior than what it is and what we've been able to test. So the test and evaluation have a different relationship here, and this is, I believe the community's understanding of this is still emerging. But the cost and schedule of tests is going to be different, and the underlying knowledge and actions of the testers is going to be different. And to reiterate, the evaluation stuff becomes much more challenging. In my simple view of this stuff, I came in very much from the physical world, not from the cyber world. In the physical world, you can test in one place and you have a pretty good idea how the system's going to behave every place else. That's completely gone, and it radically changes the evaluation function for the T&E community. Okay, next chart. Okay, so now we want to get into the details on what we're going to do. We'll start with what you need to understand about the model development and assessment, and then go to some of the specific ways in which we're going to try to wrestle with the scale of testing that's needed. Okay, next chart. So this is a simple schematic which sort of talks about what it is that we need to do for to develop an ML system. You need to collect a bunch of data. You have to find the data that you have. You may need to augment it. You may need to go and generate your own data that doesn't already exist. You collect it from the available data. You pick out, you do the extraction. You pick the part you're going to use. You have to make sure it's high enough quality. Then you have to transform it. Trivial examples would be, meters to feet type transformations, but there's much more profound transformations of that to be so you can feed it to a computer, load it up, prepare the data. Now you're ready to go. You can train the model. You check the performance of the model. You iterate the training until you're done, and then you test it and see how good the model is behaving. There are a variety of metrics that are established for doing this. So this is sort of the basic ML model development piece, but it's important to remember that this is embedded in embedded systems. This is going to be a part of an acquisition process. The testing you have at the right-hand side there may reveal that your performance isn't what you want, and you may be forced to go back and get additional data that you didn't have in the first place. Even once that is all done, there's additional loops having to do with whether or not your model is in keeping with the concept of employment you have, and whether or not the model, there's two elements, whether or not the model you have chosen, the model approach you have chosen, plays well with the concept of employment, but also whether or not you're going to have to change the approach to the model. So it's a much bigger iterative loop there as well. Most of the attention goes to the iteration in the model training and to produce a trained model. But for an acquisition program, the acquisition system is basically set up under the assumption that once you launch, it's an execution problem. There's no discovery involved. And this is flat out not going to be the case in these AI systems, and it's going to impose a bunch of additional challenges which sort of need to be faced. Okay, next chart. So we want to talk about verification, validation, and accreditation in terms of how that way of thinking, which sort of comes from the modeling and simulation world, applies to what we want to do with AI-enabled systems. And I think the way to look at it is you've got to make sure that the data you're using to drive your development is clean and accurate. It's the data you sought for this venture. Once you have done all that, you have to sample the data you're going to use. There's a bunch of issues with partitioning the data to make sure that your validation phase isn't using data that was used in the training, because that will give you invalid results. And then finally, at the end, you have to make sure that you have collected and partitioned the data you need to do the application that you want right. And this sort of maps to the stages you have in your traditional modeling and simulation of, do you have the data you asked for? Do you have the data that you want, which is not necessarily the same as what you asked for, and then they have the data that you need for the application. So this is an important feature. I would dwell a little bit about the transform and normalize. There is a lot that has to be done here, even once you've got all the data in a form where it has been cleaned and its accuracy has been checked. The data will have been collected by different people. They'll use different units. Sometimes they will use different quantities to characterize the same thing. And there's a fair amount of work that goes into that, which is often overlooked. Okay, next chart. So one of the things we sort of skipped over on the data issue is if you don't have the data you need, the data you need may not exist, and you may be put in the situation where what you actually have to do is generate it yourself. This poses a lot of challenges. I think the most important element about this to realize is that while this has been thought of primarily in terms of the development activity, the 5000.101 basically reserves the right of the test community to use synthetic data in the testing of models and systems as they come out. Let me pause for a second and link this back to the evaluation function. You have this situation where you've trained a model in some particular arena. You've trained a system in some particular arena. You are aware of the fact that the model, and therefore possibly the system, will behave very differently with small changes in the environment in which it's operating. And you still have to draw, I was going to say sweeping conclusions. That may be a little bit too big, but you have to draw conclusions that cover enough of the space that's of interest to the Department of Defense. The test and evaluation community, particularly in the 5000.101, is reserving the right to use synthetic data in part to expand the understanding for evaluation purposes of what's going to happen in areas that are different, perhaps significantly different from what you have trained on. The T&E community has, particularly with DOT&E, has sort of put a stake in the ground that they may do this, but I don't believe we have worked through yet how we would do it, how would we have confidence in doing it. You can imagine, if you have any experience with the Department of Defense at all, if not everybody likes the answer that comes out using synthetic data, there's going to be a bar fight that emerges. All right, next chart. So modeling simulation, I have 2 points for this chart, and then maybe we'll dwell on that a little bit longer. The first is you can do a lot to substitute for open air testing by driving your ML models with modeling and simulation instead of the physical world providing them the input. You can do this in the development. You can do it. You can also use these kinds of techniques in test planning, so you can optimize the information from the conducted tests. There's a danger here, which I'll return to in a minute. The use of the modeling simulation to support future development shows promise. However, there have been proposals to try to simplify this process by making a traditional digital model of the machine learning model. And this is basically invalid. It's my view that any testing of software that's not tested on the actual tactical software you plan to deploy is misleading, is likely to be misleading. For the machine learning cases, you have this dimensionality problem that they are sensitive to all sorts of elements of what is fed from the real world, which are not included in your typical digital models, which will drive this. An interesting feature about this that is not yet fully recognized, DoD Instruction 5000.61 is about modeling simulation, and it essentially requires a VV&A process on any data or models used in defense systems. The wording clearly, as written, applies to machine learning as well. And the validation authorities, with a couple of exceptions, are not specified. So that's sort of it's in the hands of the components, but exactly how they're going to handle it is unclear. Any circumstances in which the modeling simulation is used for test and evaluation, though, the test and evaluation community will almost certainly insist on having a role, a role in the accreditation. One more subtlety having to do with the modeling simulation is that because the real world drives your ML models with all sorts of extraneous details, which they will respond to, and your digital modeling and simulation that's used for driving usually will not. Even your validated modeling and simulation probably has to be re-verified, revalidated, reaccredited for use in driving your ML systems. So there's a potential here for substantial efficiencies, but there's also an additional set of hurdles to go through to make sure you're doing it all right. Okay, next chart. So formal methods and the modeling and simulation are in one high level sense in the same category. They are techniques you can use to deal with the state space and sensitivity of the deep neural nets and related ML systems. They've used mathematics and logic to evaluate how the software will behave. I'm going to go over this chart fairly quickly because my estimate is there's 150 people online who know more about this than I do. But the essential point within the guidebook is to flag this as an area for future development and attention. It is one of the things that is probably distinctive. There has not been a lot of calls for this, but I think it's potentially valuable enough that it warrants some additional attention. I think I will let it go at that. Next chart. So there's been a lot of talk about explainability and trustworthiness in the AI realm. In terms of what you're doing in the development and what you are exploiting in the test evaluation, visibility into the inner workings, particularly into the decision-making that the machine learning provides to the larger system, provides evidence that the system is trustworthy, gives both the developers and the testers some sense of what the performance is and what it's likely to be in situations outside the testing. What you want to try to drive to is that the model will do what you want it to, won't do what you don't want it to, and that it has been constructed in a way that humans can work with it. This last part I haven't worded very well, but essentially one of the drivers of this third bullet is the computers can do things very fast. You have to make your system in such a way that whatever human control you want to exercise can be exercised on the timescales that humans react, rather than just the timescales that the computers react. But these are the three elements. Jumping back to the acquisition link again, it is relatively common in developments to put instrumentation into systems that are in development to help with the development. These usually get pulled out for swap constraints. In some cases, the instrumentation is put in where the warhead is planned to go, because you don't want to do your early lab testing with actual warheads. For AI systems, particularly AI systems that are likely to evolve after fielding, the visibility is likely to be of value continuing after fielding. This changes some way how you want to do development, because then that swap burden is not something that can be exploited later. It's going to be fielded with the system under those circumstances. And there are a variety of trade-offs both in the development and in the final ownership having to do with visibility here. Okay, next chart. So for 15 years or so, the test communities, both within R&E and with DOT&E, have been talking about the need to shift left. The early language on this was actually before we had the adaptive acquisition framework, but it applies to all of the pathways. And essentially, the driver for this is to prevent late discovery of problems, late in DT, or even worse, during operational test when you think you were just about to launch into production. The idea was to engage early, in my words, or to shift left in the more common words, so that you've learned the things you need to learn early enough and you forestall, preclude these late discovery of problems. We have struggled with that for all 15 years, in part because the mindset has been that we need to do operational stuff, and we need to do full system stuff earlier. You can't do full system stuff earlier. The system doesn't exist. So the CDAO documents that I referred to before shed some light on this and set us up to make some of the early steps at making this actionable. They basically made the point that you can't afford to do a complete exhaustive set of operational tests. You also don't know which are the things that are going to actually be used. So you're sort of stymied about how to do this. The additional point, of course, is that for shifting left in time, the early engagement, the full-up systems don't exist. The prototypes may not even exist. So you have to find some other way to deal with this. And essentially, the way that you need to deal with it is to switch the focus from trying to do operational light tests to using your understanding of operations and missions to identify those features of the technology being used or the design of the system that are most likely to be vulnerable. So it is a change of emphasis about what is important about what you measure, and sort of a criticality of the mission orientation, mission engineering, the operational insights that tend to be well embedded in the operational test community. You want all of those insights to tell you what parts of the system need thorough characterization because they are most likely to be vulnerable as the development proceeds, and the environment in which they are embedded changes. So this is a step, perhaps only a baby step, but a step in the direction of making the shift left operational. You're not in a position to make things to do fully mission relevant testing. You can use your mission and operational understanding to drive the testing of components that you do so that they are well understood and the most vulnerable components are well characterized. So if changes have to be made late, they can be made quickly. And you also decrease the probability of the discovery of late problems. That's a lot of words about a small step, but we've been waiting for this step for a while, I think, and I think a lot of the credit goes to the articulation in CDAO about how you can't really quite surround this problem with your operational testing. All right, next chart. On to our closing chapter here. I alluded to the fact that the stovepipes are all broken by AI. There's a particular bunch of them that we dealt with: contracting, requirements development, design trade-offs, et cetera. Let me walk through some of these now. So the next chart. The contracting one is particularly obvious. You get what you pay for it. There's been a tremendous amount of attention over the past year to the fact that T&E is going to be very difficult to do if you can't get access to contractor data, where by contractor data, I mean data the contractor may own that they use for their training, but also data in the sense of how their models worked and how they chose the modeling approach they did. The VV&A of data and models is required, as I mentioned before. But who gets to do this or who is required to do this is unclear. You can also get some insight into the development processes and use that to contribute to the overall assurance that will help get your system through the various wickets near the end game. And with the visibility, instrumentation of the machine imposes a swap burden. All of these things the contractors may object to / require money for. The data often is something that they will regard as intellectual property. The models also, if it's intellectual property, they want somebody else doing VV&A on it. The development processes may be trade secrets. There are some companies that develop more efficiently than others. And the swap burden, which is imposed by instrumentation, may be regarded as putting them at a competitive disadvantage to someone who is not planning to do the swap burden. So all of these things, the contractor IP, the imposition of a swap burden would have to be contracted for. I think, based on my morning's reading, I was reminded that this is a bit of a hornet's nest. The Army plans to contract to change all their contracts on maintenance so that green suiters can perform maintenance that they are qualified to do. Most of the contracts are written so that, no, you can't maintain that because that would reveal IP, which you don't have access to. It will be interesting to see how this plays out. Secretary of the Army and others are engaged in wanting to change the contracting. There are others who will not want that to happen. In the T&E arena, collapsing back now to the guidebook, the role for the T&E professionals is to advise the PM about how valuable the information will be in terms of giving you better, cheaper, faster test evaluation program. And then it's up to the PM with his contracting officials to negotiate with the contractor and figure out whether or not the book is worth the candle, whether or not you want to do this or not. There's been a number of calls within the T&E community for very complete and aggressive information to be mandated. This is going to stir up a hornet's nest, not only with the OEMs, but with Congress in all probability. Nevertheless, collapsing down to the T&E again, they can advise this information is going to be worth this much to us, and then let the contracting officers and the program manager decide whether or not it's going to cost more than it's worth. All right, next. Forgot about the requirements. The requirements are relatively straightforward for the mandatory requirements. The one thing I would talk about, which is relevant and may be sort of cyber adjacent, is if the interoperability, if the communications links are guided in some way or controlled in some way by AI, you will now have a very different sort of interoperability testing that you have to do. If they're not controlling that, the interoperability and sustainment testing as worded in the mandatory KPPs is not very much changed by the presence of AI. But don't be fooled. There are tremendous things in a more broadly viewed perspective on sustainment and interoperability, which will require a lot of testing specific to any capability solution. So it's a strange fence straddling here. The mandatory KPs and mandatory attributes probably most of the time will not matter much, but there will be a lot of attention required in the capability specific ones. And you got to keep your eye out for the fact that if you have the AI systems controlling elements of your communications, that is going to bump up into the mandatory KPPs. Let me jump on again. Next chart. Again, language pulled out of the system. The concept of employment has to be baked into the life cycle and into the design. The two are linked in ways that are more profound than the concept of employment with purely physical systems. And I will cite our experience with self-driving cars to illustrate this sort of problem. The concept of employment on the self-driving cars, as it started out, was sort of that you could put a limitless number of chore-doing features into the car. You know, it can steer, it can change lanes, it will brake automatically, and this will ease the driver's burden. The problem with the concept of employment is that if you bore people, they stop paying attention. The concept of employment is that you can provide them all this support so they don't have anything to do, and they will still be at the ready to take over in the case of emergency. So this has been the concept of employment. It is fundamentally failed. The design work has attempted to deal with this with a variety of tricks. They put eye trackers to make sure you're paying attention to the road, you're not reading a novel. They put haptic sensors on the steering wheels to make sure you're actually gripping the steering wheel. And the response of the drivers has been to wear sunglasses and hand weights on the steering wheel. So this is a commercial world example of how difficult it can be if you don't have how people will actually behave. What is your concept of employment? What are the features of the AI system? All right. Time's a waste, so let's keep moving. The design trade-offs, I think the testing of AI systems is challenging enough that it may be coming true on some of these AI systems that the testing burden is significant. As soon as it becomes significant, it has to be part of the design trade-off. The schedule impact or the difficulty with approvals could drive your design choices. That's the written, politically correct way of saying this. If I was in a room and I was looking at you, I would step off to the side to indicate that I'd gone off script. I know from interactions with a variety of people that designers are making decisions. They're making design trade-offs at the bench level because they don't think they can get the system approved if they use an ML approach and they go back to an algorithmic approach. So this is already happening, and it's something that requires some amount of attention. Next chart. There are challenges for accreditations and certifications. I don't want to dwell on this given the time. The challenges are basically the same things you have. Is the data any good? Have you got the machine interface, the sensitivity to small changes? And if you go to, it flips to the next chart. If you go to the guidebook, we sort of try to do a mapping between what these challenges are and the various sorts of certifications that you may care about. But I'm not going to subject you to that at the moment. Next chart. Okay, we're going to have to know different things. We're going to have to run our tests differently. The development increases opportunities for test engagement. The cycling of the T&E involvement for AI systems is like what people talk about with agile development, but on steroids. Synthetic data is both a challenge and a solution. The concept of employment has to be involved throughout. And at all times in the test and evaluation, and particularly the evaluation, you have to struggle with the fact that you can't really get your arms around as much data as you would like. Nothing is like the old make-believe days where you have written requirements and the ground vehicle can cover the terrain at the given speed. Check. Let's move on. Okay, let's see what's next here. Harkening back to the beginning, we're very much interested in getting people involved with what's coming next, and what's coming next is, we believe, a second edition. We benefited enormously the first time. We had something on the order of 50 participants in helping shape both what was important and how it ought to be treated. Next chart. The details on this point is, as I mentioned before, second edition is planned. It will incorporate additional stakeholder feedback, pretty much as we can get. Part of it will be a view from the range. This has been the feedback we got the first part was, a lot of it was sort of, headquarters type, policy type things, but we need people who actually do the testing for a living involved. We need more interaction with safety and sustainment user groups. I think that's a stated intention in the guidebook, in the current guidebook, but also new and expanded content. We admitted earlier that we hadn't done much on generative AI. We also didn't do much on reinforcement learning. Both of those were changing sufficiently fast that we felt it was imprudent to try to put it into words a year ago. The reinforcement learning is, I believe, becoming increasingly important for navigation solutions, which are likely to be hitting development fairly soon. Risk management in AI systems was called out by the sponsor as an important area to expand into. And the formal methods, there's continuation there that ought to be done because of its possibility for essentially retiring parts of the state space so that you don't have to measure stuff there. So with that, I appreciate the opportunity to talk to you. Next chart. This is how you reach us. Questions or comments. And for future version of the guidebook, we've set up a website so that people can put in comments asynchronously and all that. So thanks again for the opportunity, and I would be, not only I, but Sarah also would be delighted to take any questions you have or listen to your advice.
If it's okay, I've got a couple of things that I've been trying to track the chat as we've gone through here. So I've got a couple of reactions to some things that have been said. So let me follow back with a couple of things here. One of the points about synthetic data was, what do we do about the problems associated with synthetic data, picking up artifacts that are built into the data itself through the process of training? Yes, right? Synthetic data is, as Dave said, a solution and a problem. And unless we actually have real world data, there is very little chance that we're going to get a good enough baseline of what the expected behavior is that we can say, yes, this is something that we ought to deploy. And I think that that's one of those challenges that wraps into the other point that I saw come up a couple times in the chat, which is, so what do you do if your system that you're testing is a proprietary system where the company comes back and says, awesome, love that you want to test, no chance, because the data is proprietary, the process of gathering the data is proprietary, the process of testing the data is proprietary. If they basically say, no chance, right, what can you do? Well, a couple of you in the chat pointed out that there are contract mechanisms to address this, but I think the bigger question is what is then the vendor actually trying to sell you? Because if they're not going to give you access to the data, they're not going to give you access to the process for producing the data, and they're not even going to give you access to knowledge about how they have themselves performed testing on the system, then I would actually start to ask whether or not they're just trying to sell you some vaporware. Because if those things can't be met, then it doesn't seem like there is a there at all. That is a bit of a challenging statement, but it seems as if there are companies out there that want to push AI as a sales mechanism rather than an actual technology. And I think one of the challenges that we've come against with not only drafting the guidebook, but also at looking at and presenting this to a couple of different audiences is that there's a lot of confusion about, gosh, what is actual AI anymore? And we don't want to wade into, ontologies. We don't want to wade into questions about what the definition is. But when it comes down to what can you actually do with the thing that is AI, if data is what creates it and they don't allow you to test or to even have access to the data, then I would really seriously question what they're providing as actually being AI. A couple of you asked us some interesting questions about data poisoning. So there are some questions about the integration with the FedRAMP process for cyber testing and whether or not we addressed that in the guidebook. No, we did not, and we should. And that's a really great point. And I really encourage you to either, any of the emails that you see up here, pop us a note and say, hey, I want to talk to you about whatever it is that you guys just brought up. Really want to hear more about the data poisoning one, because there was a long sort of stream of text there, and I'm still watching it continue here, and I'd love to continue to have that conversation with you, because we want to make sure that this next version of the guidebook does what I think a couple of you also asked, which is how do you make this the most practical document possible within the limits of practicality that come up through all sorts of other challenges of speaking to a number of different audiences, talking about AI holistically, et cetera. And so anything that you want to know or that you want to talk to us about, reach out. Because I thought that there's a really great statement that I think was probably pushed a little bit offhand, but I thought was a great bumper sticker for how we are sort of living in the context of test and evaluation of sort of early AI right now, which is that we're playing chess in the dark. I can't remember who said that, but I want that on a t-shirt, because right now, particularly if we're talking about deep learning, and one of you said we need to have like deep learning as a high watermark, not machine learning. Heard. We did take sort of machine learning as a high watermark here because we wanted to be able to address what we know more concretely about AI, what we know about supervised learning systems, and not necessarily wade into more of the squishy frontier, as Dave said, whether or not we're talking about generative AI or reinforcement learning, right? We didn't want to address that because we didn't have enough confidence in the information when we started to talk about this. And in fact, we just didn't hear from as many people as necessary to really feel like we had good things to like hammer through in the context of the guidebook. But back to the idea of playing chess in the dark, particularly with respect to generative AI. Oh dear, right? How we're going to test this really brings up a lot of questions in terms of what's the role of cyber? What's the role of test and evaluation? What's the role of the proprietary companies that are serving this? What's the role of the end users, and how do they actually wrap together into something that looks like a comprehensive enough, right? Realizing that get to full comprehension is not really possible anymore, right? How do we get to it's comprehensive enough, we have a reasonable basis of expectation for this is how this system shall behave? It's going to take a different way of thinking about who needs to be involved and how they need to be involved. This harkens back to some of the last points that Dave made on the slide, which is like, this is going to change our timeline. This is going to change our costs. This is going to change those people who are really part of all of this. And finally, one of the last points that I think I wanted to also just make, and this maybe comes to something that maybe all in the cyber community can appreciate as much as anyone in the AI, particularly the DevOps or the MLOps side can appreciate, which is we keep saying we want to test the models, but as you know, and as we know, it's sometimes just the plumbing for the models to be able to get data in, to manipulate the data and push the data out. So how do we actually start to talk about testing AI as a system rather than continue to talk about testing AI as just a model? Like one of you asked, how can I get a better access to like Google Colab or another environment that doesn't take so many permissions to access? It's a really great question. Let me know when you solve that problem. But the question really becomes, how do we test these as really sort of systems of systems and closer to full up systems that takes the plumbing seriously, that takes all of the interpenetrating circuits into this AI system as something that has to be treated, not just, you know, a Python package or a PyTorch framework system, right? Because that's really where we're going. And we're hoping that the next guidebook, particularly with your feedback and your interaction, will take us more towards that horizon rather than talking about what we were confident enough that we could know and go more towards the space that you live in, which is, again, a bit more squishy, a bit less certain. So, yeah, we have more questions than answers. Yes, you do. And I am confident that Phil and Sissy will be happy to send all of these questions to us. And if they are pinned to your names, we'll be in your inbox, right? Asking to talk to you more about this, because this is fundamentally a group effort, right? This is a community effort. And, you know, we can talk about this all day because we love it. But at the end of the day, we also want this to be something you can use, right? And something that you can use to have better conversations with the teams that you have, but also to have better interactions with your vendors, with your uppers, in order to be able to get to that final question is, can we be confident enough that this model is something that we can deploy safely and securely?
So let me just jump in for a second. The unstated plan is that since the official launch of version 2 is going to be in the next fiscal year, what we want to do is interact with as many people as possible who can build us the foundation. You know, what's in and what's out, what is essential to treat, in how much detail over the summer. This is the kind of activity that doesn't necessarily take a lot of billable hours, but it tends to take a few months. So I want to second Sarah's comment that we will take seriously any comments you send us, and if you send us your name, we'll probably get back to you.
Phil, did you want to push up any questions that you saw in particular that you think we didn't voice over well enough?
Sure.
First and foremost, thank you for the presentation. This is probably one of our most well-attended webinars, and you can tell by the activity in the chat that this is obviously something that's relevant to our community. Yeah, so the Q&A is officially open. Please put all your questions in the Q&A. I know the chat has a bunch of questions in there as well. We have about 5 minutes left based on the scheduled time, but the stream won't automatically drop off at 1. I'm willing to ask as many questions as long as the presenters are willing to answer. If we don't get to your question within the live session, we do have your contact information. I will be sharing the chat and the Q&A with our presenters, so they'll be able to reach out to you, or you can reach out to CSIAC, and we would love to make that connection as well. But yes, I see that you addressed most of those, but I'll just go with some of the Q&A. I'll read these out loud for the benefit of those on the phone. So the first question we have is from Angie. She says, does the guidebook cover what metadata requirements are needed for AI developmental test and evaluation?
No, and we will. That's a good question.
Yep. Our next one we have is from Ben. Are any of the services exploring developing an AI test range, quote unquote?
I haven't heard this. Have you?
I don't.
All right. Thank you. Next question from Dale. Are there any recommendations on how test resultant decisions and or recommendations of the embedded AI?
Again, I think we have this confusion. Okay, that's a pejorative word, but it's the one I got. The focus tends to be on the full-up system testing. We still need a lot of improved capability at the model level, getting the metrics right, learning how to match the technical quasi-academic metrics to mission outcomes. That can be done at a much smaller scale, financially. And so it's much harder to tell how much of that is actually happening in the course of some of the system developments.
I saw another question that come up about the test ranges or another point, and that's about what integrations are there and what compute is available. Yes, right? Unless we have essentially a tremendous amount of aggregated compute available to have full testing of these models, we're going to run into some challenges in creating a reasonable test range. I'm sure that there's some creative solutions to identifying, unused compute and distributed computing in order to be able to satisfy that need. But an AI test range is going to be, I agree that it's definitely something that is needed, but is also something that's going to itself require a tremendous amount of effort to actually aggregate. So a couple of you asked something about, is there a plan for a future for a shared repository for contractors and agencies to submit information? I haven't heard of that.
If so, it would be a CDAO effort. We should be able to check that. We should be able to check and see what CDAO has done in that arena. I think it's the kind of thing they would like to do. It runs into all of the collaboration versus competition IP issues. But we can check with the CDAO folks about how far they've gotten down that path.
Because that question about storage, I thought was a good one as well, right? How in the world are we going to actually store all this data? How are we going to securely do it? Invariably, people are going to ask for air gapping. We're going to be talking about some implementation of some zero trust architectures that I don't think we've really thought about yet. But all of these are really good points, and that question about best practices for AI test range, that seems like something we probably need to start talking about. Whether or not this guidebook is the appropriate venue for that, I don't know. One of the challenges that we have, and again, come at us, please, in terms of what we should include is whether or not that's in scope. Our view of what the scope is for something like this may not necessarily be what your scope might be. So again, let us know. And again, happy to talk about that. Phil, I think we are probably going to run into our 1 o'clock WebEx smash. Should we?
Yeah. No, I mean, so the stream won't stop automatically. So
Okay.
Okay.
I just made that announcement to let people know that
Okay.
we won't drop off the stream automatically. So we're fine. We can keep going if you guys are willing, or we can take some of these questions offline. It's really up to you.
Well, one thing at least I would like to say is that what's in scope and what's out scope is going to be much easier to influence over the summer than once administrative and contracting folks here and with the sponsor get involved with, we want you to do this and not that and so forth. So the better you can inform us between now and September 30th about what you think is important and what level it ought to be treated with. This is the window of opportunity for you influencing what we do with a very low effort on your part. Right? Yep. If you come back and see us not in September, but in December, when the train's already running down the track, it's going to be much harder for everyone involved.
Madhavan, I would think that unfortunately, we're probably not going to get too far down the road of agentic AI. I think that that's a really great question. But if we're going to start talking about the integration of multiple large language model systems, multiple transformer-based systems, I think we are going to need to treat that as like a 201 or 301 level addition, sort of a really deep dive appendix for people. I think it's a super important point, but I'm not sure that's something that's going to cover everything for the community that's going to work. But if you have thoughts on how you think that should happen, again, we're all ears for this. So, all right.
Thank you very much. No, we appreciate it. I think there's probably a good stopping point here. I'll save the chat. So if you typed in your question, it's either in the chat or the Q&A. We have your contact information. I'll share that with the presenters. And if for some reason they don't get back to you, you'd like CSI to make a connection, we can do that. Also, take advantage of our technical inquiry service. Submit a technical inquiry to CSI. We do free research for you on your behalf, and we'll make sure we'll get with the folks at IDA to kind of help there. We put the link into the chat for today's presentation, as well as the link to the guidebook itself. Please check back to the CSI webinar announcement. This was recorded, so you'll be able to rewatch the recording. If not, you can go directly to our YouTube page for that as well. But this was great. I would like to thank David and Sarah again for their time. Great presentation, and hopefully we see you guys next month for the next monthly CSI webinar.
Thanks for the opportunity. This was a treat.
All right.
Thanks, y'all.
Take care.